have quite a few people have joined at this point, so we'll get started. Once again, my name is Aaron Dobos. I'm with the National Renewable Energy Laboratory, and I'm glad you're joining us to learn more about scripting in SAM. Okay, so first, just want to put this in context with all the other webinars that we have going on this year. We're sort of middle way through our series for this year. The schedule is here shown on the slide. We have a couple more webinars coming up in the next couple months, and I'd encourage you, if you're interested, to sign up for those as well on the SAM website under the Learning page. These webinars are free. They all begin at the same time at 1 p.m. Mountain Time, and of course you must register, but that's free, of course. And the link at the bottom here is a link for where you can learn. So today's webinar is all about scripting. These are the topics we'd like to cover. What are SAM LK scripts? What are some examples? How can you get started with scripting? What are the differences between scripts and macros that are available in the new version of SAM that came out in the fall? Then we'll talk about some useful features of LK. We'll look at 2 case studies of complicated analysis that was done using the scripting feature. And then I'll go through a detailed demonstration where I actually create a script live that does some calculations, reads and writes some files, and shows off some of the useful capabilities. And then finally, hopefully, we'll have some time at the end of the hour for some questions and answers. So why would you want to do anything with scripting? SAM is pretty powerful as it is, but scripts let you control SAM automatically without clicking anywhere in the user interface or typing commands. So, for example, you may want to run a very large simulation where you run the analysis of what a PV system LCOE might look like across the whole country. Now it would be awfully tedious to set up 30,000 different weather files in SAM and run those manually. So, clearly some automation is needed to generate a map like what's shown here. You can also do detailed simulations and generate custom output files that you may want to read into some other data processing system, or you might have generated inputs for your simulations from another, let's say in Excel, and you want to just do a batch run of the simulation data that you have. You can also do your own calculations in scripts and post-process the results. So there's a lot of flexibility that lets you go well beyond what is already programmed into the same user interface. And what is LK? It's really just the name for the SAM's built-in scripting language. If you've ever used Microsoft Basic or Visual Basic for applications, commonly known as VBA in Excel spreadsheets, LK is analogous to that. It's a pretty straightforward but powerful programming language, and it's nice because it's very tightly integrated into SAM. So it's easy to run simulations, get outputs, and do those kinds of things. Of course, the scripts that you write will work the same way on Windows and the Mac version on OS X. And so it's a really flexible way, but of course you need to know a little bit about computer programming. So I'm going to assume that everyone who's signed into the webinar is at least familiar with SAM. We're not going to go over the basics of SAM or what it does. We're really going to focus on the scripting here. And I'm also going to assume that you've maybe have a basic sense of programming, so variables, if, then, else type statements, loops, and things like that. But at a whole, the point of the webinar is to give a good overview of what's possible. And then the last thing I'd point out is that scripting in the SAM user interface is different from using the SAM software development kit, which is another way you can get at the underlying algorithms in SAM. So with the SDK, you can write your own programs in other programming languages in C, Python, or other languages, but they don't give you all the I mean, you get all the power of the algorithms, but there's a steeper learning curve for taking advantage of that feature. So basic user interface, it's pretty simple. There's the main window where you enter your code, then a couple buttons that we'll talk about in more detail. The run button is most important, of course, where you click and then SAM will run the script. And if your script generates output, then it'll show up in the console at the bottom half of the screen. There's also some buttons on this toolbar for looking up SAM variables, SAM input and outputs, and also for looking up function names and how to use those functions in your script. So a really quick example. I'm just going to talk through this 5-line script just to give you a sense of what you can do. So the general concept is that you can have a script to control a case. And so the first, assume that we've created a simple PV Watts residential financing case in SAM, and you can use that as you normally would in the SAM user interface. You can also write a short program in a script to control it automatically. So the first command in line 1 is to tell the script which case you want to be working with. So there's this call to the active case function in line 1 that tells the script to use the residential PV case. The second line changes an input variable, and it seems pretty straightforward. There's the set command where you pass it the name of the variable and the value that you want to give it. So let's in this example, we're setting the tilt variable to 21.5 degrees. Then line 3 we call simulate, which is analogous to pressing the simulate button on the user interface. And then in line 4 we create a variable called energy, and that's a variable inside the script, and we're giving it the value, we're assigning it the value of the annual energy, which is retrieved from the SAM simulation engine using the get function. And then using the out ln, so out with a new line command in line 5, we're going to print some data, some outputs to the console, and you can see we're converting the units of the retrieved energy output from kilowatt hours to megawatt hours. So when we run the script by clicking the run button, then you can see annual energy in megawatt hours 6.86476 is shown in the console window. So that's a really simple script. It doesn't do a whole lot, but it gives you the general structure of what's involved. So working with SAM variables. So if we take this script that we talked about in the previous slide, and we want to work with a different variable, but as you probably noticed, the names of the internal variables, how do you find out what those variables are called? So you can click this variables button at the top, and suppose we wanted to programmatically change the system's azimuth as well. And then you can start typing in the search field in the dialog, and SAM will filter through all the variables it knows about and list the ones here. And you can see that it found the azimuth variable, where the first piece of what it found is the label, and then what we need in the script, which is in quotes here, which is the variable name. And then when you click OK, it takes the variable name and inserts it directly into the script. And we'll go, in the live demo later on, we'll go through doing this for a couple variables, so you get to see it in action. A little bit more about the scripting language. The main things I want to show here are what are the general ideas or things that the scripting language can support. At a basic level, the language supports numbers and text strings for data. So you can do multiplications, divisions, text strings. You can add strings together. So most things that programming languages typically do. Then we have typical constructs such as logical statements, if, then, else type constructs, as well as loops. We support the while and for loops. And the syntax for that is we can look up in the reference manual. And we'll go through an example of a loop later on. As for data structures, LK supports single and multi-dimensional arrays, as well as tables, which are also commonly known as hash tables or dictionaries. And we'll use both of those data structures in our example script at the end. You can, of course, write your own functions in the scripting language to be able to divide your large program into more manageable chunks. And then the scripting language also has a really big built-in library of functions that can be useful for different things. So we've already seen basic output to the text console, but there are also ways to do graphical outputs. There's a library of math functions such as trigonometric functions, logarithmic, exponential, those types of things. There's a whole set of functions for working and parsing, scanning text strings. You can read and write files from your computer, scan folders. So if you wanted to list all the weather files, for example, in a folder on your hard drive, you can do that automatically. There's some powerful functions for working with CSV, or comma-separated value files. There's functions for exchanging data directly with Microsoft Excel. I would note that that's actually only available on the Windows version. The Excel linkages on the Mac don't exist. The scripting engine also has plotting functions that you can use for graphing your data. You can work with web services, download files from the internet directly in the script. There's sampling functions and functions for stepwise regression analysis if you're doing a stochastic type simulation. And then, of course, there's a whole set of SAM-specific functions that will let you work with cases, variables, and results. And we got a little preview of that in the quick example before. So a little bit more about built-in functions. It seems like there's a whole lot of them. How do you find out which ones you want to use and how do you use them? You can click this Functions button under the red star, and that'll pop up a scripting reference that lists all the functions that are built into the scripting language. They each have a description of the parameters and return values that those functions expect and return. And you can scroll through this list to find, and they're sort of categorized into groups. Also, you'll notice in the screenshot here, when you're typing your script into the editor, you'll get these helpful pop-ups that also pull from this built-in function documentation library to give you context help while you're writing your script. So how can you get started and get some more help? The SAM help system, if you click the help button anywhere in SAM, it includes an overview of scripting. There's also a full reference manual. It's maybe 40 pages or so that details every detailed feature of the scripting language. And so if you need to know more about how to work with multi-dimensional arrays or nested tables or other sorts of more complex features, then you might want to look in the reference manual for the scripting language. We've also started a cookbook of examples on the SAM website, and this is, even with all this documentation, sometimes it's a little tricky to get to know how to use a particular function that takes in maybe a more complex set of parameters. And so we've started putting up example code for different types of functions. Like there's examples for working with the CSV files. There's a plotting example. There's an example on how to run simulations in parallel on multiple processors. So there's a lot of example code that we're working on expanding that. And then you can also search LK in the online forum, of course, to see what other questions and problems people have run into. So scripts are really powerful, but sometimes you want to hand out, you might write a script and you want to hand it off to somebody so they can use it, but they're not a programmer and they might be intimidated by there being a lot of code. So macros are basically just LK scripts that are designed to let people run them who don't know anything about scripting. And you can pretty easily take a script that you've written, package it up as a SAM macro, and then it'll just show up in SAM's macro library. There's information in the documentation or in the forum about where to put your script file so that it shows up. And then you can put in some documentation and create a really simple user interface for somebody to change some variables and then run your script. And then SAM comes with a set of macros for commonly used features, such as doing some calculations about an auxiliary gas heater if you're doing a solar water heating simulation. There's also a macro to check weather files for errors or to convert them from different formats. So there's a lot of different types of scripts that you can write that do different things. Also, if you're wondering how one of these scripts or these macros that are included with SAM, how they work, you can always look at the code behind a macro because it's just a script. At the red star here, there's a View Code button that you can click, and it'll pop up the macro in a script window, and you can edit a macro or make a copy and make modifications to it for your own purposes. So I think that's all I'll say about macros for now. This is pretty new. This has only been in SAM since November. So, but there's a lot of capability that's that builds on what the basic SAM software provides. So now I'll just quickly present two quick case studies, just one slide on each, to show examples of the types of things you can do with scripts. So in this example that somebody here at NREL did, somebody asked us to do a batch calculation of PV system economics, and they gave us a spreadsheet with 30 addresses. Each had a different PV system size, a different system cost, a different utility rate. So, I mean, if you were going to do this by hand, that would be sort of, well, cumbersome. And so we wrote a script that took in this spreadsheet and automated the whole process. And so weather data was automatically downloaded for each street address from the NREL National Solar Radiation Database. And then we've modified the system size and the utility rate and the cost for each simulation, went through a loop, and then wrote all of the simulation results to a file. And it's a pretty modest script, maybe 100 lines of code, and it ran pretty fast. So and then of course the person who asked us to do this came back with a modified spreadsheet with another column of, why don't you modify this cost as well? or this financial parameter. And so it's a lot easier to then just make a couple quick changes in script, run it again, and you've got your output. And it's a lot less error prone. So there's a lot of value in sort of approaching these types of problems with scripts. And then, okay, there's some pictures. And then also at NREL, another script that was developed by the CSP group was to figure out how to optimize CSP Power Tower's design parameters to minimize the levelized cost of energy of the system. So this was one of the most complicated and pretty impressive uses of the scripting language that I've seen. This person programmed a genetic algorithm in script and sampled a bunch of different parameters about the design parameters of the CSP system within selected ranges. They used over 10,000 simulations running in parallel from the script language to generate this results space that was then optimized with the genetic algorithm to minimize the LCOE. And then they were able to write all these results to files and generate plots as well. So pretty powerful simulation that otherwise you couldn't really do with SAM if you weren't doing it with the scripting language. Okay, so we'll switch gears here, and I'll get into a live demonstration of writing a script. We're going to answer a pretty basic question here. What is the best DC to AC ratio to use for a PV system in Portland, Oregon? And the script that I'm going to write here is maybe 30 lines long, so it's not very big, but it'll show some interesting features of the scripting language. Of course, this is not a super complicated example, so you could probably accomplish it just as well using the parametric analysis capability that's in SAM. But based on the previous two slides, you could very quickly see how a task like this could get more complicated and where the scripting language would really come in handy. But anyways, we'll show how you can load input files, create an Excel, run a bunch of simulations, save results, and plot results, and create images of those graphics. So I'm going to now get out of PowerPoint here. We'll start SAM. Then we'll start a new project. And we're going to just use PV Watts for now. It runs quickly, so that's advantageous for doing it live. But you can do scripting with any of these technologies and any of the financial markets, so you're not limited by what I'm showing here. So we'll create the case. And then just to go a little bit beyond what's in the default, we'll switch to Portland, Oregon. That's my hometown, so why not? And then we'll just look at the design page, system design page here. We've got a basic PV system. We'll leave everything alone. What we're going to look at is what is the best value for this DC to AC ratio. And that's for people who might not be familiar with it. It's the ratio of the size of the DC PV modules to the size of the inverter. And we'll see that there's sort of an optimum value of that, which is a trade-off between competing factors. Okay, so as I mentioned, we'll learn how to read files in from Excel. So I need to create an input file. And what I'm going to do here, I'm just going to have a one-column data file. We'll put in a header. We'll call it ratio. And then we'll just put in a bunch of values. 0.7, All right, that should be enough runs for now. So I'm just going to save this on my desktop for convenience. We'll leave it called book 1. And then although Sam can directly access XLSX files, I'm actually just going to save this as a comma-separated value file also, because the Excel functions are a little bit more complicated than I have time to demonstrate here. But there is an example for using Excel directly on the cookbook, on the LK scripting cookbook on the SAM website. So I'd encourage you to look there. So I'll save a CSV version of that file as well. And sure, we'll let Excel save it. Okay, so now we'll go back to SAM, and we'll create a new script. You can you do that through the SAM menu at the top. Click New Script there, and we'll get a window that pops up here. I'll just move it around a little bit and give ourselves some room. So the first thing that I'm going to do is read in that data file. So I'll just create a variable and use the CSV read function that's built into SAM. And then the little helpful documentation comes up. The first parameter is the file name. So I'll type in the file name. And then you can see that there's a second parameter called table options. And table means that that's an LK table structure. And then there are various options that I can pass in. So the options are listed here. So there's an option to skip header lines, whether to translate the CSV file as numbers. By default, it returns text strings, which is what a CSV file is stored in, and whether to return a table where each column is an entry in a table, or a two-dimensional array or matrix. So the way I'm going to skip the header line, because I really only care about the numbers. So I'm going to skip one header line, and then I want the reader to interpret the data as numbers. So I'm going to say numeric equals true. And I'll close the curly brace and close the parentheses. So this is all I need to do to read in that file. These curly braces here create an LK table structure with these fields and values. So if you'd like to know more about that, I'd recommend taking a look in the reference manual. Tables are used a lot in LK to pass various options and other parameters to functions. So they're really useful. And then just for the moment, I'll just print this data to the console so we can see what was read in. And then we'll write some more code. So if I run it, oh, that's what we would hope for. We have all those values of the DC to AC ratio that we want. Okay. So the next thing, as you may recall, we need to tell the scripting language which case we're interested in working with. So there's a function called active case, and we pass in the name of the SAM case that we're working with. And in this case, it's just untitled. Of course, it'd be best to rename that at some point. And now we're just going to go through all the values of that DC to AC ratio, set it in SAM, run the simulation, and save some results. So we'll write a loop using the for syntax. The first parameter here is the counter, and we'll initialize it to 0. We'll go until while I is less than the number of ratios. since ratios is the ratios variable is a two-dimensional matrix, the pound operator in the scripting language returns the length of the array, and then we'll increment by 1. All right. So here we'll start typing. We'll just create a local variable r for the value of the ratio, and I'll read it out of the ratios matrix. So I have to put in this ratios represents a matrix. So the first index is the row number in the spreadsheet, and the second index is the column. And since here I only have one column, I just use the first element, which is the 0th element in the scripting. Arrays and matrices in LK are 0-based indices. Okay. And now I want to set the variable in the case, set the variable, but I need to figure out what that variable is. So we'll click on variables, and this dialog pops up. We'll type maybe DC to, there you go. So we found it. And it looks like the variable name is DC_AC_ratio. We'll click OK, and it'll fill it in right there. Set DC to AC ratio to R. Next, we'll simulate. So we just call the simulate function. And then let's get an output from the simulation, maybe the capacity factor. So CF is just another local variable. We'll assign it to the capacity factor. Well, I need to look up what the capacity factor variable is. Capacity factor. It's in outputs, and it's an annual output. So we'll take that, click that, and click OK. And it'll fill that in for us right there. Okay. Before I go any further, I'll save the script, just so it doesn't disappear if something goes wrong. And then if we run this now, or maybe we'll we'll put in a output so we can see what those capacity factors are. So here I'm just outputting a text string simulation plus the index of the simulation plus the actual value of the capacity factor. So we'll save it and run it. And here you can see the DC to AC ratio here changing as Sam goes through each simulation, and the capacity factors are showing up here in the console window. So that's great. We have our results. But let's do a little bit more work. Suppose we want to dump all of this to a spreadsheet. So we'll just create a table called X, and we'll just save some data to it. So I'm going to save the annual total kilowatt hours produced by the PV system as well. I need to use the get function to retrieve it. And then we'll also save the LCOE from the simulation as well. We'll use the nominal LCOE for now. Okay, so we've saved a bunch of data. And so this is going to be X is a table with fields named DC-AC ratio, capacity factor, energy, and LCOE, and each of those are arrays. So if I use the CSV write function, and I give it a file name, and the table, then it'll generate that CSV file directly. So let's run the script again. And then we can look on the desktop and here's results.csv. So we can open that. And this is what it looks like in Excel. So you see that it generated the data file with the AC ratio, the energy, the capacity factor, and the associated LCOE as well. Okay? So let's go back to the script, and we'll show off one more feature, and that's the built-in plotting library. So let's create a plot of the levelized cost of energy as a function of DC to AC ratio. So the first thing I'll do is call a function called new plot, which basically just gives me the option to remove any existing plots that might be around from previous times I've run the script. Next, I'll use the plot command, and as our x values, I'll use DC-AC ratio. As the y values, I'll use the LCOE. And then the third parameter, again, is a table. So we'll start with a curly brace, and we'll send in some options. So we'll make a line plot. We'll make it red. And we'll give the line, we'll make the line a little wider than the default. Okay. Let's go ahead and run this and see what comes out. There we go. So Sam created a little plot window with the DC-AC ratio and the LCOE with this red line. So just as we asked for. We'll close that, and we'll make two little modifications to make the plot prettier. First, we'll add a title. We'll use the plot option function, and then we'll set the title equal to impact of DC-AC ratio in Portland. We'll also hide the legend, since we only have one series in our plot. And then why don't we give the axes some labels as well. So we'll use the axis function, and the x-axis is known as x1, and we'll give it a label. We'll call it DC-AC ratio. Then axis y1, label is LCOE, and that's cents per kilowatt hour. And then another useful thing here is if you're doing a lot of simulations and you want to generate lots of plots, there's a function called plot out, which can generate a PNG or other file format output file. And we'll create a PNG file on the desktop. plot1.png. Save this, and let's see what happens. There you go. There's a plot with the axis labels, the title, and then we can also, I think this is the let's see, where is that file that was just created? So here's plot1.png, just created. If I open that, there's an image file of the plot that you see in the window. So this can be useful if you're generating lots of plots programmatically for a report, or you want to see things. You can also plot multiple lines, of course, by calling the plot function multiple times. And so there's a lot more you can do with plotting, and we have some examples on the website that give you some more options and ways in which you can create plots. So I think that concludes this demonstration that I had. We can have some questions and time for question and answers here for the next 15 minutes or so. I see that my power cord is not working, so I have 9 minutes left on my computer if anybody would like to see a demonstration repeated or anything. So I think thank you very much for attending. Again, this webinar will be recorded and will be posted on the SAM Learning webpage for viewing later. And then there's additional webinars coming up that you can register for. So why don't we go ahead and open up for some questions if there are any. You can either type your question into the chat window, or you can, I think you might be able to request to ask it over the phone as well. But let's go look, see, I'm going to look through here, see if any questions in the chat window. Oh, there's a question about making the genetic algorithm-based script available. I don't know if that's available. I'd have to talk to the author of that script. If it is available or a portion of it is available, we can look at making it, posting it on the SAM LK Scripting Cookbook website. And that would be possible, potentially. Somebody asked to see the full script on my screen. Hopefully that's what you're asking for. There's the full script. We'll be posting the demo script here, as well as the associated input and output files, alongside the PowerPoint and the recording of this webinar. So you can get everything that we did today. See any other questions? We'll just stay on the line a while longer to see if any questions arise. It looks like there aren't too many at the moment.
Aaron, I had a thought, which is perhaps we could, this is Paul Gilman, just had a thought that maybe we could show where the macro folders are in the installation.
Oh, that's a great idea, Paul. Thanks. So going back to the macro, so here's the macro button in SAM. And it flips to this page where there are all the different macros that you can use. So if you want to add a macro to the SAM macro library, all it takes is for you to open up the folder where SAM is installed on your computer. On my computer, it's down here under SAM. And oh, sorry. So that's my computer battery.
Okay.
I had a power cord here, but it clearly is not working.
Here, I can show it. It looks like maybe there's a question. I'm going to unmute Mike Francis. Mike, did you have a question? Okay, maybe not. So I just switched over to my computer. I think you see my screen now. Let me get Sam up here. So as Aaron was showing, you've got a list of macros here, and the macros that appear here depend on what kind of case what you have. So we've got a PV Watts residential case, and these are the macros that are available for that case. WindLCOE is a macro that I'm working on, so it's not in the official release. But these macros are stored in the SAM installation. So if you're interested in setting up a macro for your use or for your colleagues' use, go to your SAM installation folder. And then under Runtime, there's a macros folder. And the macros are these LK scripts. And if you put the macro in the top level of this folder, then the macro will appear for all cases that in SAM. Or you can create these folders if you want the macro just to appear in the specific case. So for example, this macro will only appear with the commercial financial model. And this one only appears with the flat plate PV model. And then, and Mike says that this is the question he was trying to ask. Great. And are you still on audio, Aaron?
Yeah, I'm here.
Okay, great.
If you want to just read out the question, I'd be happy to answer it. Or you can answer as well.
Right. So there's just a comment here about this is a lot to digest in 1 hour. Any chance we could offer another webinar in the near future after we've had a chance to review the workbook and run samples? That's a possibility if there's enough interest. I would suggest if you've got further questions, post them on the SAM support forum, and we're happy to answer questions there. There's a few active discussions right now on LK scripting. So that's another resource.
I think if there are any particular topics that come up that we could dive into more detail on, I think we could look to putting together some more specific examples or training materials for features that sort of need more content around them. So we're happy to take suggestions.
And there is a fair amount of documentation, as Aaron mentioned. I think the one thing that's missing is detailed documentation and examples on how to use all of the functions in SAM. So that the LK reference is a good, sort of talks about data structures and sort of how to use LK in a general sense. But a lot of the specific details about, for example, the plotting functions that Aaron demonstrated are not well documented. So, if you come across those kinds of questions, please let us know, and so that we can build sample scripts for you to use. And as Aaron mentioned, we introduced LK in November, so we're still sort of catching up on the documentation needs.
And one thing I also didn't mention was the previous version of SAM, for those of you who might have been using SAM for a long time, had an older scripting language that you could do similar things in, and it was called SAMUL for SAM User Language. And when we redid the SAM user interface, we moved to this new language, which was really a lot more powerful and lets us do things that weren't possible in the past. And while the concepts are really the same in terms of setting your active case and setting input variables, running simulations, getting outputs, working with files, the syntax of the functions and some of the programming structures have changed. But eventually, I think it's definitely for the better.
And it looks like there are a few questions about the SDK. So I've put up the SDK website on the screen here so folks can see it. So if you're interested in running the SAM simulation engine from outside of SAM, so the LK script is sort of analogous to VBA and Excel, where you run VBA from inside Excel. The SDK is a separate set of tools that allows you to write programs in C++ and a handful of other languages. So if you're interested in that, we have a separate webinar that's on the learning page here. We have a list of our recorded webinars. There's an SDK webinar that introduces the SDK, and you can download it here on the SDK website. And part of the SDK tool set is something called SDK Tool, which is a little development environment that uses LK. So you can run LK scripts outside of SAM as well through this SDK tool. And I see that Janine has been typing all of this too as I'm speaking. So.
I suppose if there are no further questions, I think we'll wrap it up for today. Again, Aaron Douglas at NREL, thank you for joining our webinar, and hopefully we'll get to see you on a future webinar as well.
Great, thank you, Aaron. And go to the learning page on the SAM website tomorrow or early next week to download a recording of this session along with supporting materials. And thanks again for your participation. We'll